Hi guys, welcome back to In Case of Econ Struggles. Today we're doing a shorter video. We're talking about the utility maximization problem still, but we are talking about perfect substitutes and perfect complements. This is related to the longer utility maximization problem. So as we're going through, if you want to refer back to that longer video, feel free. Timestamps are below in this video, so you can come back as you please. And if you get some value out of this video, make sure you like and subscribe to keep up with this video and all the econ struggle videos. So without further ado, let's get into it. Let's quickly start by talking about perfect substitutes. The way we're going to talk about perfect substitutes is we are going to go back into that grocery store, or we are back at that table making the list of what we want to buy at the grocery store. But this grocery store only sells two goods. It sells Coke and Pepsi. But we don't have a preference between Coke or Pepsi. We just like soda. So we only care about the number of soda that we have in our shopping cart, or that we are going to put in our shopping cart when we get to the grocery store. We do not care how much of that soda is Coke and how much of that is Pepsi. So our utility function for this problem might look something like U of Coke, Pepsi, and I'm going to make this a little easier. I'm going to refer to Coke as P and Pepsi as P. So U of Coke Pepsi is equal to Coke plus Pepsi. Again, notice that this does not depend on how much Coke and how much Pepsi we have in our cart. If I have 5 Cokes and 0 Pepsis, my utility is 5. 5 plus 0 is 5. If instead I had 0 Coke and 5 Pepsi, I have the same level of utility, it's 5. And if I did something like 3 Coke and 2 Pepsi, well, my utility of that bundle, of that shopping cart, is still 5. So as you can see, no matter how we switch the number of Coke and Pepsis, as long as we have 5 sodas, our utility is going to be 5. Now, the way we are going to think about this problem is, unsurprisingly, if I like Coke and Pepsi the same, but Coke is listed as $2 and Pepsi is listed as $1, then I am going to buy all Pepsi and no Coke because they give me the same amount of utility, and Pepsi is $1 cheaper. I can buy more Pepsi if I spend all my money on Pepsi. So the key takeaway here, unsurprisingly, is that you buy the cheaper good, buy all of the cheaper good. There are situations where this doesn't hold, but again, we're just trying to be simple. We're just trying to think about the intuition. And I think here the intuition makes sense. If I like Coke and Pepsi equally, and Pepsi is way cheaper than Coke, then I'm going to spend all my money on Pepsi. So let's put this into a graph just so we can compare it. We will return to this graph in a minute, but let's just say that our budget constraint, we have $10 to spend. So 10 has to be greater than or equal to the 2 Cokes plus the Pepsis. So if I put Coke here and I put Pepsi here, I can buy 1, 2, 3, 4, 5 Pepsi, or I can buy 4, 5, 6, 7, 8, 9, 10 Pepsis. And this is my budget constraint, so I'll put that in blue. And my utility function is a line. It's Coke plus Pepsi. I'll write this down just so we can keep track of it. And so this bundle, this green bundle, let's make it a fun color. Let's make it orange. Here's my bundle. We said that I want to buy all of the cheaper soda, so I'm buying all Pepsi. So at this orange bundle, note that my indifference curve goes all the way out here to 10. So let's extend this axis a little bit. 6, 7, 8, 9, 10. This pink line is my indifference curve for utility of 10, because if I have 10 Pepsis, according to this utility function, my utility is 10. Now let's think about a slightly different scenario. Let's say, again, we're back in this store. Let's just copy and paste let's just take our entire shopping cart, our entire grocery store setup. Let's bring it down and do some slight modification on it. So let's take it down here. All right, well now, maybe more realistically, most people have a preference between Coke or Pepsi. So let's say that this person, I don't know, let's say he likes Coke more, he's a Coke person. So our utility function is going to be slightly different. Let's say our utility function of Coke and Pepsi, maybe it's 5C plus B. Maybe this person likes Coke 5 times as much as Pepsi. And now, again, we're trying to decide how much Coke and how much Pepsi to buy. Now, before, in the original utility maximization problem, we said that negative marginal utility of Coke over marginal utility of Pepsi had to be equal to the price of Coke over the price of Pepsi. And what I want to do here is I want to change this equation very slightly. Just algebraically, I'm going to move some stuff around, and I'm going to get to that negative MUC over price of Coke is equal, let's just make this a plus, because this is really a minus here, so let's just get rid of the negatives. And this is really marginal utility of Pepsi over the price of Pepsi. Now you might be wondering, what does this mean? Why did I do this? This equation here, this is what we call bang for buck. This means if I spend $1, an extra $1 on Coke, how much better off am I going to be by spending that extra $1 on Coke? And it makes sense that in our optimum, in our normal utility maximization problem, the extra bang, the extra utility I get from spending $1 on Coke should be equal to the extra bang or the extra utility I get from spending another $1 on Pepsi. If they're not equal, then I need to readjust the amount of Coke and Pepsi I'm buying. So let's just work this out algebraically. The marginal utility of Coke, that's the derivative of this utility function with respect to C, that's going to be a 5. Price of Coke is 2. We'll put a box here because we haven't yet decided if it's equal or not. Marginal utility of Pepsi is just 1, which is just 1. So this, the sign that goes in this box is a greater than. So notice that at all levels, at all possible shopping carts, my bang for buck or my extra happiness from spending another $1 on Coke is higher than Pepsi. So I always want to buy more Coke, which means that in this setting, I want to spend all money on Coke. Another way of thinking about this is, yes, Coke is more expensive than Pepsi, but Coke, I like Coke so much better than Pepsi that it is worth it for me to spend all my money on Coke because I like it so much better. That's another intuitive way to think about this question. And if before, say it this way, before, so I'll just put it before, we had the marginal utility of Coke over Coke was 1 over 1, and the marginal utility, sorry, this is 2, price of Coke is 2. The marginal utility of Pepsi used to be 1 over 1. So this sign goes this way, and we bought all Pepsi, which is what we found earlier. The takeaway here is because we like them differently, we like Coke more than Pepsi, even though the price of Coke is higher than Pepsi, in this case, it is still worth it for us to buy more Coke. And then in the first case, it was not worth it, so we bought all of the cheaper good, we bought all Pepsi. Now, let's talk about complements. Complements are some things that go perfectly well together. So for instance, I always think of maybe chips and guac. This is gonna be a terrible picture. Let's just write it out. This is like chips and guac, maybe something like peanut butter and jelly. Or another real easy example, I think, is pairs of shoes. So we're used to buying shoes as a pair. But let's say you could buy them separately. So let's say left shoe and right shoe. And this is the example I want to use for perfect complements because I think that it makes the most sense intuitively. I think it's the easiest to grasp. So let's take it and run with it. So perfect complements means fixed proportions, that we want to buy things in fixed proportions. Unsurprisingly, when it comes to shoes, we want pairs of shoes. So if we are standing in the shoe store, again, there are left shoes on one side of the store, there are right shoes on the other side of the store. All I'm thinking as a consumer is I only care about the number of pairs of shoes. What does that mean? That means that, well, one pair of shoes is one left, and I'll make this one a little better, one left and one right. But one pair of shoes is also 10 left shoes and one right shoe. It's also one left shoe and 10 right shoes, because no matter how many left shoes I have, if I only have one right shoe, then I only have one pair of shoes. So an example utility function, a way you might see this on a homework or a test or in your textbook, is you might see the utility of left shoes and right shoes is equal to the min of left shoes and right shoes. So looking back at our three examples here, one left and one right, the min of that of 1 and 1 is 1. So I have one pair of shoes. The minimum of 10 left shoes and one right shoe is 1, which again, we know that I still only have one pair of shoes. And one left, 10 right, again, I only have one pair of shoes. And the way this is going to look graphically, if we throw down a quick axis here, let's put, I don't know, we'll put left shoes on the x-axis and right shoes on the y-axis. So here's one left shoe, and here is one right shoe. Let's do a fun color. Let's do pink. So what is one pair of shoes? One pair of shoes is one left shoe and at least one right shoe, or one right shoe and at least, oh, I guess we're not going to make the line, and at least one right shoe. So that is the indifference curve for utility 1. We can also, I don't know, maybe we'll do 3. So 3, let's have 3 pairs of shoes. It could be right here. Very similarly, here's 3 left shoes and just a bunch of right shoes. And here are 3 right shoes and at least 3 left shoes. This is the difference curve at value 3. Now we can't take the derivative. We can't figure out the marginal utility with a min function. It's kind of weird. So the way I like to do these problems is I like to say, well, a pair of shoes, I'm going to let that be equal to P, and that's one left shoe and one right shoe. So now my utility in terms of pairs of shoes is equal to the number of pairs of shoes I own. For the budget constraint, let's say that a left shoe is equal to $1. It costs $1 for a left shoe, and it costs $1 for a right shoe. And let's just say that we walk into this store with $6. Let's say $6 is equal to our wealth, our income, the amount of money we walked into the store with. Then our budget constraint initially starts out as left plus right has to be less than or equal to 6, but we can put them together and we can say, well, 2 times the number of pairs I want to buy, because each pair is a left shoe and a right shoe, so that's going to cost $2, has to be less than or equal to the $6 that I walked in with. So we know that, well, this means my budget constraint, I can afford at most 3 pairs of shoes. And because our preferences are monotonic, convexity isn't a super issue here because they're already in perfect portions. We're already doing mixtures. Then my answer to this question is going to be that I'm going to buy 3 pairs of shoes. Now, if you liked this video, make sure to subscribe for future videos. If you have questions, feel free to add them into the comments, and we will see you next time for another econ struggle.